And today I'd like to continue our lesson on solving quadratic equations. We just finished factoring. Today I want to show you two other techniques to use to solve a quadratic equation if it does not factor. First way is going to be completing the square. So first thing I want to do is get the quadratic equation in this form. This looks a little bit different than yesterday. First off, note that I want a 1 right here in front of my x squared. If there's something else, I'm going to need to divide it off. We have an example coming up of this. Also notice that the constant is over on the right side by itself. I don't want it set equal to 0 on this. I want everything that has an x on the left side, everything that does not have an x is going to be on the right side. My next step is going to be take whatever this b is right here in the middle, and I'm going to want to divide it by 2 and square it. So I just use this little symbol right here, b divided by 2 squared. The whole point of doing that is making it so what is on the left side now will factor. It'll factor into a binomial squared, actually. And then I can use something called the square root method, where I can just take the square root of the left side, the square of the right side, and I should be able to arrive at the answer. Just to warn you, the answers today on some of these problems are going to look a lot messier than the answers that we had previous when we were factoring. So I want to solve these by completing the square. Okay, I'm going to work A with you, and then I'll let you try B. So remember, first up, I want to make sure there's a 1 right here, and there is. And I need to make it so this -2 is on the other side. So I'm going to add 2 to both sides of my equation. Now notice I left a hole right there. In that hole, I'm going to do step 2. I'm going to take this 8 out, and I'm going to divide it by 2, which is 4, and then square it, which is 16. The addition property of equality says if I add 16 to one side, though, I need to add 16 to the other. So that makes it so my left side factors nicely. My left side factors into y plus 4 and y plus 4, which would just be y plus 4 squared. And that should happen every time you get a binomial square. Take the square root of both sides, get y plus 4 equals, I need a plus or minus here because negative square root of 18 and negative square root of 18 is going to give me 18. And so that's going to give me, if I subtract 4 from both sides, I get y equals -4 plus or minus, and be careful with this 18 right here. It's got a perfect square. That's just 9 times 2. So 3 square roots of 2. Kind of got bunched up there. I'm going to let you try part B. I've already got the -21 moved over. So you give this a shot, pause the video, and come back and see if we match answers. Okay, so I got -7 and -3. That answer came out a lot nicer, meaning that if I were just to add 21 to both sides, I would have got something that was factorable. So this completing the square is a good backup if you don't see how something is going to factor. Now, I want you to be careful of how you simplify on these, okay? A couple of common mistakes. First of all, if I'm squaring a binomial, that doesn't mean that I square both of these. It cannot go over this plus sign right here, so this is not equal. Also, when I'm taking the square root of a binomial, not that you should on this, but I cannot just take the square root of both sides. That is not equal. Okay, so a couple common mistakes on that. All right, I'm going to skip C. If you want to see it work, be sure to ask me. I'm going to go straight to a nasty one. I'm going to have us appreciate this other way of working the problem. Okay? So remember, I've got to make it so this is going to be a 1 right here. So my first order of business is going to be divide everything by 3. X squared minus 5/3 x minus 10/3 equals 0. You see how it's going to get nasty now? So now, I need to make it so that this -10/3 is added to the other side. And so now I've got to unfortunately take this -5/3 right here. I need to divide it by 2 and then square it. If I divide it by 2, that's going to give me -5/6. If I square it, That's going to give me 25 over 36. Just simply square the numerator and square the denominator. So I am going to put 25 over 36 here, and 25 over 36 here. Yeah, it's just getting messier and messier. I've got a shortcut right here I want to show you. Okay. Instead of trying to think of two factors of 25/36 that adds up to give me -5/3, I realize this one's just going to factor like 2 before that I worked. If you go back and look at it, I'm missing an x right there. I've always got an x right there. Here's the kicker. What I can always do is bring down the sign from the middle, and then I can always just take the square root of this 25/36 and bring this back to a 5/6. And that will be factored. Go back and check the last two that you worked. I bet you it worked on those two. Need to add together these fractions on the right side. Let's see, that's going to be 145 over 36. Okay, I've got the same steps, even with these nasty numbers. I'm going to take the square root of both sides. That's going to be plus or minus. Let's see, the square root of 145. I don't believe it simplifies. The square root of 36, though, will turn into a 6. Add 5/6 to both sides, and I have my final answer. Positive 5/6 plus or minus the square root of 145 over 6. Would I work a problem like this using completing the square? Probably not. I would probably go to a quadratic formula. Just a review for your quadratic formula. Remember that everything's in the form ax squared plus bx plus c equals 0. So I want to get it into this factoring form. And whether it factors or not, I can always find out what x is by just plugging that a, b, and c into the quadratic formula. And if I simplify this using my order of operations, it will tell me what x is every time. If you want to, you can go into your notes. This is actually my son Justice singing the quadratic formula when he was 2 years old. Just put that on there to make you realize that I do expect you to memorize it and be able to work it out. But memorizing it should not be a hassle for you. Okay, I'm going to skip A. I'm just going to work B with you. Okay, so I get x equals, I'm going to go ahead and write this up here one more time. The square root of b squared minus 4ac all over 2a. And it's just going to be a matter of plugging in a, b, and c into this equation. So the b is -6. So I take the opposite of -6, that's going to be a 6. B squared. Well, if I square a -6, that gives me 36. It should always be a positive number right there. A is 9, C is 1, all over 2 times A. Now something unique happens on this. This 4 times 9 times 1 gives me 36. I subtract 36 from itself, just get 0. Square root of 0 is 0, meaning that my answer is simply going to be 1/3. What that also means is that if I would have caught it, this would have factored down nicely, making it so it's just a little 2-step problem for me. And I would still get the answer as 1/3 if I would have caught that for a factor. Let's pause the video again and have you work part A, and then we'll come back and check our answers together. All right, this is the answer I got. Kind of had to work into part B over here. A couple things I want to mention on this. I'll outline here in red. Notice the negative sign did come down with the C. Okay, A, B, and C can be negative when working this out. I simplified my square root of 44. Make sure we're still doing that. And then this 2 that's on bottom is just a common denominator that can go with both sides. So then after I put it with both sides of my numerator, I can then simplify this all the way down to -3 plus or minus the square root of 11. Oops. one thing I want you to be careful on, I want you to be careful simplifying it. If you do not have to split that apart like I did on the last problem, but if you do, you can't just be choosy and say, well, I'm going to cancel the 2's and not cancel a 2 out of this guy as well. If you cancel a 2 out, you have to cancel a 2 out of all 3 parts of this formula, leaving you, so that'll make this a negative 2. So be careful about that. It's a very common mistake. Put those on there. We could still solve those with or without. I'm going to skip those for now. And just in case you're still struggling with quadratic formula, I will work it one more time. I'm going to work it over here on part D, since that's already. This part C over here, it wouldn't be too bad to complete the square with. You ended up getting a pretty nice answer on it. This part D over here, I want to work it. So x equals, try it without writing out the formula this time. So negative b, negative 4, positive 4. Square root of b squared, 16 times 4 times a times c, all over 2 times a. Let's see, 4 times 2 times 3 is 24. Now notice I'm not canceling those 4's. I see they're going to cancel later, but I don't want to cancel them yet. I'm going to try to do all my cancellation in one step. 16 minus 24 is a negative 8. Now that negative 8, we talked about this last week. I can break that apart as a negative 1, a 4, negative 2. Negative 4 plus or minus a negative 8 would turn into a 2i squared over 1. I like to break it up better. If you want to cancel off all 3 of those, that's perfectly fine. You can get an equivalent answer. This breaks it all the way down to 1 plus or minus I squared to 2.